Yeah, is the screen visible?
Yes, sir.
Okay. Anyway, I think it almost 3 weeks. I think we met, right? Yeah, almost 2 weeks around. So let me recall this once again. Just a quick recall of what actually we have done till now. There is a something called finite differences. The difference is nothing but you find the difference between the values like this: y1 minus y0, y2 minus y1, etc. And these are known as the finite differences. Okay. And there are two things. One is called interpolation. Another one is called extrapolation. Suppose if we don't know the function y equal to f of x, we know only the tabulated value, that is corresponding to x equal to x0. We know the value of y. Corresponding to x equal to x1, we know the value of y, etc. up to xn, we know the corresponding value as y1. From this table, we want to compute what will be the value of y corresponding to x equal to xi. Suppose this xi lies in between x0 and xn. The process of finding the value of yi is known as the interpolation. And if this xi lies outside this interval, suppose that this is the interval. Suppose assume that you are given a table from 0, 1, etc. up to 10. From 1 to 10, we were given the values of y. Some value of y is given. Okay. Suppose if you want to compute the value of y, this is x and this is y, corresponding to x equal to 0.5 or x equal to 1.2, etc. 0.5, 1.2, everything lies in between 0 and 10. Therefore, this process is called the interpolation. And if you are computing the value of y outside this given range, for example, if you are computing the value of y corresponding to x equal to 10.5 or 11 or 12, etc. So 10.5 lies outside this interval. Therefore, this we call it as extrapolation. But in some book, they refer authors refer only interpolation, that actually mean both interpolation and extrapolation. Okay, that is the process of computing the value of y corresponding to any given value of x is known as interpolation, right? And there are two types of problem. One is at equal interval, another one is at unequal interval. So first we will see the problems at equal interval. Suppose if it is at equal interval, in general we will write it like this: x1 we will write it as x naught plus h, x2 we will write it as x naught plus 2h, etc. xn we will write it as x naught plus nh. Okay. And using this table, we will determine the values of f of x roughly, or f dash of x, for some intermediate values of x. Okay. And there are first these three differences we have seen. One is the forward difference. It is defined as, this is the difference actually: y1 minus y0, y2 minus y1, etc. yn minus yn minus 1. These are the differences. And only the notation is different. Suppose if I denote it by using forward differences, I denote this value by delta. This is capital delta. We will use the second suffix. The second suffix is y0. So we will use y0. This y2 minus y1, we denote it as delta. What is the second suffix? y1. Okay, so y1. Similarly, yn minus yn minus 1, we will write it as delta. What is the second suffix? Yn minus 1. Okay, this is how we will denote it. So if you look this into the other way, delta y0 is defined as, what is the next value of y0? y1 minus the same y0. Similarly, delta y1 is, next value of y1 is y2. So y2 minus same value. So in general, this is how the delta yr is defined. What is delta yr? Next value, that is y at r plus 1 minus same value, that is yr. So this is the definition of first order forward difference. So once you define the first order, in the same manner we can continue to define second order, third order, etc. And then in general, the pth order difference is defined as p minus 1th order at, this is in terms of yx. Okay. The other things is, we can define the same thing in terms of function also. In terms of the function, this is the definition. Delta of f of x is next value, that is the value of the function at x plus h minus same value, that is the value of the functionality x. Okay, so very simple. Remember clearly, forward difference is defined as the value of the function at the next argument, that is f of x plus h, minus the same f of x, whatever it is. Okay, and this delta is called the forward difference operator. And when you compute the forward difference table, right, the values is same. The values are same. Y1 minus y0, you write it here. Y2 minus y1, you write it here. Y3 minus y2, right in between these two. Then y4 minus y3, y5 minus y4. Then similarly, this value minus this value, this value minus this value, this value minus this value, etc. Okay, write it like this, but only the notations are different. And if you are using the forward difference operator notation, then this leading diagonal will be in terms of y0 and its forward differences. That is y0, delta y0, delta square y0, delta cube y0, delta power 4 y0, delta power 5 y0. So that is this diagonal, that is from top to the bottom. This will be in terms of y0 and its forward differences. This diagonal will be in terms of y1 and its forward differences. This diagonal will be in terms of y2 and its forward differences. This will be in terms of y3 and its forward differences, y4 and its forward differences, etc. Okay, so whenever you construct the forward difference table, the diagonal elements will be like this. Okay, next, backward difference operator. The backward difference operator is defined as same value minus previous value. That is del yr is same value, that is yr minus previous value, that is yr minus 1. Similarly, we can define the higher order differences, delta square, delta cube, etc. So here actually I am using the first subscript. So y1 minus y0, the first suffix is y1, so I denote it as del y1. Here the first suffix is y2, so del y2. Similarly, here it is yn, so del yn. Okay, so backward difference operator is defined as same value, whatever here you write it, minus the previous value, one step prior to this, that is yr minus 1. Okay, then if I construct the backward difference table, you will get like this. So in the case of backward difference table, this last diagonal will be in terms of y5 and its backward differences. You see y5, del y5, del square y5, del cube y5, del power 4 y5, del power 4 y5. Similarly, this diagonal will be in terms of y4 and its backward differences. y4, del y4, del square y4, del cube y4, del power 4 y4. Similarly, this will be in terms of y3 and its backward differences, y2 and its backward differences, y1 and its backward differences. Okay. So if I construct the backward difference table, then the diagonal you have to look is from bottom to the top, bottom to the top. But in the case of forward difference, top to the bottom. Okay, that's all. This is a backward difference table, and in general, f of x is del f of x is same f of x minus the function value at the last argument, that is f of x minus h. This is a backward difference. Then we have seen the central difference also. The central difference, what you do is, in the case of forward difference, how we have written this y1 minus y0, we have written it as delta second suffix. In the case of backward difference, how we have written this y1 minus y0, we use the first suffix, that is del y1. Okay, actually del y1 equal to del y0 equal delta y0 equal to del y1 equal to y1 minus y0. But in the case of central difference, we take the average of these two suffix, that is 1 and 0. You take the average, that is 1 by 2, you denote it as delta y by 2. Similarly, here you take the average of 2 and 1, so it is 3 by 2. And take the average of n and n minus 1, so it is n minus 1 by 2. That's okay. So you can note that all the values are same. All the three cases, the value is y1 minus y0, but only the notation is different. If you use the forward difference, delta y0, if you use the backward difference, del y1, if you use central difference, small delta y1 by 2. That's all. I hope up to last class we have done this only. And in the case of f of x, we will define it like this. Delta f of x is x plus h by 2, x minus h by 2, you find the difference. Okay. Now, in case of central difference table, look at the center. The center is x3, okay, x3, y3. So if I draw a horizontal line at the center, you can note that all the even powers will coincide. Like delta square exactly, you will get delta square y3. Then delta power 4, you will get here delta power 4 y3. Then at delta power 6, you will get delta power 6 y3. Similarly, you will get delta power 5 y3, etc. here. But in the odd powers, there will not be any value here. Here, there are no values. Okay. So that's why it is something at the center, we are getting the same subscript, right? Suffix. So y3, 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 etc. So it is called central difference operator. Okay. So let me recall it once again. If you use the forward difference operator, this diagonal will be in terms of y0 and its forward differences, y1 and its forward differences, y2 and its forward differences, etc. If you use the backward difference table, this last diagonal will be in terms of y6 and its backward differences, y5 and its backward differences, y4 and its backward differences, etc. And if I use the central difference table, exactly at the center, at odd powers, this value will be same. The suffix will be same. Delta square y3, delta power 4 y3, delta power 6 y3, etc. That's all. Okay. So then, whether we have done these problems, can anybody reply me?
No, sir.
No. Okay. So all this we have to just use the definition, nothing else. So we have to evaluate delta tan inverse of x. Okay. So what is the definition of delta tan inverse? Delta f of x, what is the definition? F of x plus h minus f of x. So what is f of x plus h? Tan inverse of x plus h minus f of x, that is tan inverse of x. Then apply the formula for tan inverse of a minus tan inverse of b. Tan inverse of a minus b by 1 plus ab. Then simplify this, you will get this. Okay, direct definition. Then we have to compute delta e power x log 2x. So what is the definition? Delta of f of x. What is delta of f of x? F of x plus h. So e power x plus h log 2 into x plus h. This is f of x plus h. Minus f of x. F of x is e power x log 2x. Then after that, just a simplification. Okay. So you can add and subtract e power x plus h log 2x, e power x plus h log 2x. Then from the first two terms, we can take e power x plus h common. Then we will get log a minus b. So that is log a by b. 2 will get cancelled. Then from these two terms, we can take e power x log 2x common. So we'll get e power x plus h minus e power x. Again, you can take e power x common from this. Then simplify, you'll get the answer. Okay. After this, it's merely simplification. So you just remember the definition, apply the definition, then you are done. And then after that, just simplify. Then we have to compute delta of this one. So what is the formula? F of x plus h minus f of x. What is f of x plus h? X plus h whole square by cos 2 times x plus h minus f of x is same thing. Then take LCM and simplify, you will get the answer. I will leave this portion. So just to go through, it's all about simplification. Just to take LCM and then simplify, you will get the answer. Then delta square cos 2x. We will apply one by one. Okay, so delta square, you rewrite it as delta into delta. First to write delta of cos 2x. What is delta of cos 2x?
So cos 3
cos 2
minus
times cos 2 times
yes,
x plus h minus cos 2x.
cos 2x.
Then apply the first this delta. Now to apply this first delta, you split the terms. So write delta of cos 2 times x plus h minus delta of cos 2x. Now apply the definition again. What is delta of cos 2 times x plus h? What is the next value of x plus h?
X plus H plus 1.
2h.
Yeah.
X plus
Yes, sir.
2h. So in place,
2H. Yeah.
okay, so cos 2 times x plus 2h minus same thing, that is cos 2 times x plus h. Now what is delta of cos 2x? Cos 2 times x plus h minus same thing, that is cos 2x. After that, just a simplification. Apply cos A minus cos B formula, then simplify further, you will get the answer. Is it clear?
Yes, sir.
Okay. Then sometimes you will get a polynomial like this. Okay, so polynomial actually simplification is little bit difficult. So what you do is you use the partial fraction to split the polynomial, then apply, it is easy. So we have to compute delta square of this and the delta square of this, delta power n of this, interval of differencing being unity. So interval difference, wherever h is there, we have to take it as 1. So it means that x plus 1, x plus 2, x plus 3, etc. h is 1. Okay. So first what you do is you rewrite this 5x plus 12 upon x square plus 5x plus 6 in terms of partial fraction. So factorize this x plus 2, x plus 3, write a by x plus 2 plus b by x plus 3, you will get a equal to 2 and b equal to 3. Okay, this is partial fraction. Then delta square, you write it as delta into delta. One delta, you write it as it is. Another delta you apply. So you'll get delta into 2 by x plus 2 plus delta into 3 by x plus 3. Now what is the definition? What is delta of 2 by x plus 2?
2 by x plus 2 plus 1 minus 2 by x plus 2.
So it is x plus 3, here we'll get x plus 2.
Yes, sir.
Okay, then delta of this one will become, so here they mentioned the interval of differencing is unity, right? So that's why we have taken 1. Otherwise what
Yes,
you would have done is you have to take h,
H.
okay, in general, if it is not mentioned anything. Okay, but
Yes, sir.
all this type of problem, it will be mentioned as 1 only, or even if it is not mentioned, you assume that h equal to 1. You initially you write taking the interval of differencing being unity, you solve the problem. Okay, there is no harm. Then again apply this delta, right? So apply delta of this. 2 is a constant, you can take it out, so you'll get this. Then delta of this, 3 is a constant, you can take it out, you will get this. Then apply the definition. What is delta of this one?
Sir.
X plus 3, x plus 4, you will get.
Yes, sir.
Minus same thing, write it as it is. Then delta of this will become x plus 4, x plus 5. Minus, write the same thing. After that, just to simplify, you will get the answer. Okay, just simplify, take LCM and simplify, you will get the answer. Okay. Next problem, we have to compute delta square of a into b power x. We will compute delta. What is delta of a b power x?
AB power x plus
a
1.
b power x plus 1. Otherwise,
Yes, sir.
a is constant, you can take it out. You will get delta
B
into
power
b power x. Delta into b power x is b power x plus 1 minus same thing, that is b power x. From both, you can take b power x common, so you will get this. This is delta of this. Now, delta square, you write it as delta into delta of this. Delta of a b power x already we have found, you write this. And a and b minus 1 are constant, you can take it out. Okay, so please put your mic, somebody's mic is on. If you want to talk, then switch on the mic and talk. Okay, otherwise you please mute. And then delta of b power x. Delta of b power x is b power x plus 1 minus b power x. From both you take b power x common, so you'll get this one. Okay, it's not minus, it is into. Okay, that's all. Into. Then the third subdivision is we have to compute delta power n of e power x. So we'll compute delta, delta square, delta cube, etc. Then we will generalize. Delta power e power x is e power x plus 1 minus e power x. From both you take e power x common. So you'll get e minus 1 into e power x. Similarly, delta square will become delta of this. E minus 1 is a constant, take it out. Delta of e power x is this. So you'll get e minus 1 whole square into this. So you can note that now first order difference is e minus 1 e power x. Second order difference is e minus 1 whole square e power x. Third order difference similarly e minus 1 whole cube e power x. So in general, nth order difference is e minus 1 whole power n e power x. That's all. Right? So then differences of a polynomial. Actually, this result I have used in the second unit while computing the particular integral if the right hand side is a polynomial. Okay. And I told you that time that I will prove that in the third unit. So now I am proving this. Differences of a polynomial. Right. So you take a polynomial of degree n. So this theorem says that the nth difference of a polynomial of the nth degree are constant and all higher order differences are 0. Suppose if you have a polynomial of degree n and if I compute del power n of that polynomial, so you take this polynomial as y or f of x, then del power n of f of x will become constant and all higher order differences are 0. That is, if I compute delta power n plus 1, n plus 2, n plus 3, etc., all these differences are 0. That is the theorem. Okay. So, for example, if we have a polynomial of degree 3, then delta cube of f of x is constant and all higher order power, delta power 4, delta power 5, etc., all are 0. Okay. That is the theorem. So, you take a polynomial of degree n. So it will be in the form of a x power n, b x power n minus 1, etc. up to kx plus l. Right? This is a polynomial of degree n. Now first we will find the first order difference of f of x. So delta of f of x is by definition what it is? F of x plus h minus f of x. How will you compute f of x plus h? In this you replace f of x. Wherever x is there you replace x plus h. Minus write the same f of x. So L will get cancelled. L will get cancelled. What is the constant term? In f of x plus h, you will get k times x plus h. In f of x, you will get kx. So kx will get cancelled. So you will get kh. Right? Similarly, what will be the first term? A is a constant. So from both terms, we can take a out. Here you will get x plus h power n. In f of x, you will get x power n. Second term, b you can take it out. In f of x plus h, you will get x plus h power n minus 1. In f of x, you will get x power n minus 1. So you will get this. Is it clear? Any doubt in this step?
No, sir.
Okay. So now if I expand this x plus h power n by using binomial theorem, what you will get? X plus h power n. X power n, right? Plus
Yes.
nc1, that is n x power n minus 1 h, then plus
And
nc2 x power n minus 2 h square, etc.
yes, sir.
Right? So first term is x power n and we have got minus x power n, so that will get cancelled. So your so in this term it will actually start from x power n minus 1 term. And what is the coefficient? N x power n minus 1 h. Similarly here you will get x power n minus 1, x power n minus 1 will get cancelled. So next term is x power n minus 2. So whatever here it is a polynomial of degree x power of degree n minus 2, etc. Is it clear? Therefore you will get, only I am writing the first term x power n minus 1. You will get some other coefficient. I denote it as b dash, c dash, etc. C b prime, c prime, etc. up to L prime. The L prime is nothing but k into h. It is a constant. I take L prime. Previous term, you will get x. So that is k prime x, etc. Where all these are constant. So from this, it is clear that if f of x is a polynomial of degree n, delta f of x is a polynomial of degree n minus 1. And what is the coefficient of n minus 1? The coefficient of x power n, that is a Okay, and the degree of the polynomial, that is n, you multiply with the h. So if I proceed this similarly, if suppose if I compute delta square, then what you will get? What you will get in the same manner? So write this constant a n h, you write it as it is. A n h, you write it as it is. So x power n minus 1. So what you will get? N minus 1 into h into x power n minus 2, and then the other terms. I take it as b double prime, c double prime, etc. Is it clear? Any doubt?
No, sir.
Okay. So if I proceed this, you see, first order difference polynomial of degree n minus 1. Second order difference polynomial of degree n minus 2. Third order difference polynomial of degree n minus 3. So what is nth order difference? Polynomial of degree
N minus n. That is
n
0.
minus n. X power n minus 1 n. So x power 0, that is 1. So what actually you will get is a n minus 1, n minus 2, etc. up to 1 into h power n. That is nothing but a n factorial into h power n. Is that clear?
Yes, sir.
And you can note that in this there is no h, no x, sorry. X is the variable. There is no x here. Therefore, it is a
Constant here.
constant. So if I find the higher order difference, what is it? Delta power n plus 1
0.
f of x. It is 0 because it is a constant. So we can write this as delta into delta power n of f of x. Delta power n into f of x is constant. So delta of c. What is delta of c? Next value is c because it is a
C.
constant only. Right?
C
Next
minus.
value is c. So we'll get c minus c. It is 0. So delta power n plus 1 is 0. Similarly, delta power n plus 2 to n plus 3, all these are 0. All the higher order differences are 0. Okay, hence the nth and the higher differences of a polynomial of nth degree will be 0. So what we have proved till now? We have proved that
Nth order difference is
the nth
constant.
order differences of a polynomial of degree n is a constant.
Yes.
And there is another theorem that says that the converse is also true. What is the converse? Suppose we were given a table and we are computing the differences, and if the nth differences is a constant, equally spaced is a constant, then the function is a polynomial of degree
N.
n. Okay. So just to reverse, the nth order difference of a polynomial of degree n is constant. The converse is also true. That is, if the nth order difference is a constant, then the function should be a polynomial of degree n. Okay.
N.
Differences of a polynomial. So there are some problems will be like this. So if I this is the 10th order difference. Okay. So if I multiply this, you will get minus ax minus bx square minus cx cube minus dx power 4. What you will get? 4 times minus. So plus a, b, c, d, x into x square into x cube into x power 4. That will become x power
10.
10. 10. So you will get other terms 9, 8, etc. Constant term, if I multiply all these constant, you will get the constant term. Here all are 1. So you will get finally plus 1. So it is a polynomial of degree 3, sorry 10. So what is delta power n of this one? Just now we have computed. Whatever be the constant here, that is a, b, c, d. Right? A, b,
Yes,
c,
sir.
d into 10 factorial. Here they have taken h as 1. Otherwise we can write h power 10. If I take the differences as h, you can write h power n. Otherwise you take h equal to 1, so you will get this. Okay, that's all. And the next term is factorial notation. This also we have seen in the second unit while solving the particular integral of a polynomial. We have
Yes,
written
sir.
the polynomial in terms of the factorial notation. Then we apply delta. We will write something e, etc. So I told you that time that I will prove this. So here I am proving that. So first let us see the definition. Definition is factorial x is x. Factorial x square is x into x minus 1. Factorial x cube is x minus 1 x minus 2. And in general, factorial x power n is x x minus 1, x minus 2, etc. up to x minus of n minus 1. That is this. If the interval difference is 1. In general, if the interval difference is h, then everywhere you have to write h. X, x minus h, x minus 2h, etc. up to x minus n minus 1h. Okay. And this polynomial is known as the, this notation is known as the factorial notation.
Notation.
Okay, and the main result is that if you want to find out the difference of this factorial polynomial, for example, if you want to compute first order difference of x power n, that is factorial x power n, then this says that it is similar to, analogous to that of differentiating x power n. So if I differentiate this x n
Nx
factorial x power
n
n
minus 1.
minus 1 into h. If the interval of difference is h. If interval of difference is 1, so you take h equal to 1. Okay, that is the result. But this result is not true for x power n. There is a difference between x power n and factorial x power n. Okay, only for factorial x power n this result is true. Delta of x power n is not n into x power n minus 1. Is it clear?
Yes, sir.
Okay. So now that is this theorem is useful. Then yeah. To express the polynomial in the factorial notation, we will do this. Arrange the coefficients of the powers of x in descending order, replacing the missing powers by 0. Okay. So suppose in a polynomial of degree 3, x is not there. So you write 0x. Using detached coefficients, divide by x, x minus 1, x minus 2, etc. successfully. So every polynomial of degree n can be expressed as a factorial polynomial of the same degree and vice versa. So suppose if you have got a polynomial of degree n, if you are expressing that polynomial in terms of factorial notation, then that polynomial also will be of same degree. Okay. So this is the first method. So check this. This is polynomial of degree 3. So we have got x cube, x square, x constant term, all are there. If something is missing, you write 0x. And write the coefficients. Coefficient of x cube 2, coefficient of x square minus 3, coefficient of x 3, constant term minus 10. Then leave this. So it actually means that I am dividing that polynomial by x. So if I divide this by x, what will get? So we will get 2x cube
Minus 3x
minus
plus
3x
3.
square plus 3x minus 10. Okay, you take this polynomial. So what you will get here? 2x
2x
square
minus, yes, sir,
minus 3x
plus 3.
plus 3. So what you will get? So you will get here, if I subtract, it will get cancelled. Then you will be left with only minus 10. So what is the remainder? Minus 10. So that is here. The remainder is here. What is the quotient? 2x square minus 3x plus 3. So what are the coefficients? 2 minus 3 and 3. So that is here. 2 minus 3 and 3. Now you take this quotient. You divide by x minus 1. You divide by x minus 1. Okay. Then what will be the quotient and what will be the remainder from this one? You will get the quotient as 2x minus 1. That is here. 2x minus 1 and the remainder as 2. Then again you take the quotient and then divide by x minus 2. You will get the quotient as 2 and remainder as 3. Then again take the quotient, divide by x minus 3. You will get the same thing because 2 is a constant. You will get the same constant 2. That is what actually here. But instead of everywhere writing delta x cube, x square, x, we are writing only the coefficients. That is the difference. Okay. So let us look at the method. First write the coefficient, leave the constant term. Then write the first value, always leave blank. Okay, write, or you can write 0. Okay, then add these two, multiply these two, write it here, add these two, -1, multiply these two, -1, add these two, you will get 2. Now leave this last value. Then again this you divide by 2. It means you are dividing that polynomial by x minus 2. Okay, then sorry, then write 0, add these two, multiply these two, 4, add these two, 3. Leave this. Then divide by 3, 0, right, add these two, just I'll leave it. Then we have to write from bottom to the top. That is 2, you check the degree. Degree is 3. Okay. So you will get 2 times factorial x cube plus the 3 factorial x square plus 2 times factorial x minus 10. And if I compare this polynomial and the factorial polynomial, you can note that the degree is same. What is the degree of this polynomial? 3. Degree of this factorial polynomial also 3. What is the coefficient of x cube in polynomial? 2. Coefficient of factorial x cube is 2. Constant term is -10. Here also constant term is -10. So there is no change in these three things. The degree will be same, the coefficient of highest power will be same, and the constant term will be same. The other coefficients might vary. Okay. Now, okay. Now listen here. So now you apply delta y. Okay. So if I apply delta y, I think I have not proved the theorem, but maybe I will just to give a short thing about x square. Let us compute. So by definition, what it is? What is delta of factorial x square? Factorial
2, sir, 2 factorial x power 1.
X power 1, but I'm proving the result. By definition, what is delta of f of x? F of
X plus h minus h.
x plus h. If I take h equal to 1, you'll get x plus 1 whole square minus factorial x square. F of x, factorial x square. So what is x plus 1 whole square? Factorial x plus 1 whole square. You'll get x plus 1 into, what is factorial x?
X.
X. What is factorial x square?
X into x plus x minus 1.
So what is factorial x plus 1 whole square? X plus 1 into x plus 1 minus 1. That is x.
Yes, sir.
Minus. Factorial x is x into
X minus 1.
X minus 1. Right. From both terms, if I take x common, then here you will get x plus 1. Here you will get x minus 1. Plus 1 minus 1 will get cancelled. Therefore, you will get 2x. So
2x.
x into 2x will become
2x square.
2x square. Okay, that's what I said. Delta of factorial x square is, sorry, somewhere I made the mistake.
Sir, factorial x should be there.
Sorry. If I take x common, what terms will get cancelled? If I take x common, here you will get x plus 1. Here you will get minus of x minus 1. So minus x plus 1. So x minus x will get cancelled, you will get 2. So that is 2x. Okay, that is delta of factorial x square is 2 factorial x. X is nothing but factorial x.
Yes,
in the
sir.
same way, we can prove it for factorial x cube, factorial x, in general, factorial x power n. Okay, so that is the result. It is similar to differentiation, but you can write into h if the interval of difference is h in general, or simply you take h equal to 1 and write interval of difference as 1. So here the difference is 1 because we are dividing by 1, 2, 3, etc. We are not dividing by h, 2h, 3h, etc. So here the interval of difference is 1. So what is delta y? 3 factorial x square, 2 factorial x. If I differentiate factorial x, 1. Constant term 0. Again, if I compute delta square, if I differentiate factorial x square, it is 2x.
2x.
Factorial x, if I differentiate 1, constant term 0. Again, if I differentiate, you will get 1. So you see, what is the degree of this polynomial?
3.
3. So you see delta cube is constant. That is the theorem we proved earlier.
Yes, sir.
Okay, if a polynomial of degree n, delta power n is constant. Okay, and if something is constant, then all the higher powers will become 0.
0.
Okay, so which shows that the third difference of y are constant as they should be. Okay, it has to be a constant. Then there is another method. So in the second method, what you do is this polynomial you write. We already know the highest power and the constant term, there is no change. So we need to compute only the other terms. Okay, so that I take it as b and c. So rewrite this as this constant into factorial x cube, that is x minus 1 x minus 2, plus b into factorial x square, that is x minus 1, plus c into factorial x plus d. Okay, now our aim is to compute b and c. B, C and D. Actually, D also you will get directly. You compare the constant term, you will get
Yes,
minus
sir.
10. Okay,
Minus
so D
10.
you will get directly. And this one, to compute B, what I do is you put x equal to 1, x equal to 2, or x equal to 0 to get the values. So if I put x equal to 1, this here you can simplify, you will get this. This will become 0, x minus 1, this will become 0, so you'll get a c into 1 plus d. So you'll get c plus d equal to 2 minus 3 plus 3 minus 10. So from this you will get the value of c, that is 2. Then put x equal to 2. So 2 minus 2, this will become 0. You'll get an equation in terms of b, c and d. Substitute the value of d and value of c. Simplify, you will get the value of b. Then finally substitute b and c value here, you will get this. You will get this. And in place of x minus 1, x minus 2, write factorial x cube. X minus 1, we can write factorial x square. X is nothing but factorial x minus 10. Then you differentiate, that is find delta y, delta square y, delta cube y. Here also you will get the same answer. This is the second method. So whichever method you feel easy, you can use it. Okay, so this is how we have to write the polynomial in terms of the factorial polynomial, and then okay, then find the missing value. Okay, so in some table, some values will be missing. For example, here at 45 we know the value, at 50 we don't know the value, 55 we know, 60 we don't know, 65 we know. So these two values are missing. We have to compute these values. Okay, so there are two methods. The first method is first construct the table, forward difference table. So here write x as this, you take it as x0, x1, x2, x3, x4. The corresponding value is y0, y1, y2, y3, y4. So we were given y0 is 3, y1 we don't know, write it as it is, y2 is 2, y3 we don't know, so write simply y3, then y4 is minus 2.4. Then find the differences. Okay, the differences are y1 minus 3, 2 minus y1, y3 minus 2, then minus 2.4 minus y3. Then similarly, this value minus this value, write it here. This value, write it here. This value minus this value, write it here. Similarly, this value minus this value, write it here. And here, how many values are missing?
Sir, 2.
2. So we need at least two equation in terms of y2 and y1 and
y3.
y3. Okay. So you compute up to where you are getting only equation.
Yes, sir.
Okay. Just to proceed, we will need two equations. So how many? And there is another theorem. Okay, I think I forgot to give that. Yeah, I forgot to give that. Here, how many values of y are given?
3 values, sir.
3 values are given. Therefore, we can approximate this function. We don't know the original function. Okay, We know only the function value at some values. So if 3 values are given, we can approximate this function by a polynomial of degree 2. That is the result. Because in a polynomial of degree 2, what is the general term? You will get a x square plus bx plus c. This is a polynomial of degree 2. So how many constants are there?
3 constants.
A, B, C, 3 constants are there. Okay, therefore, if 3 values are given, we can approximate by a polynomial of degree 2. That is 1 degree less. So if n values are given, we can approximate by a polynomial of degree
n minus 1.
n minus 1. And once you get a polynomial of degree, so here 3 values are given. So we can approximate by a polynomial of degree 2. And if
Yes,
you have
sir.
got a polynomial of degree 2, just now we have seen delta square of that polynomial will become
Constant.
constant, and all higher order powers are
0.
0. Therefore, this delta square y, this has to be a constant. So it means this we will get a same value. And all higher order power, delta cube, delta power 4, etc., all are 0.
0.
Therefore, this it has to be equal to 0,
0.
and this
And
also has to be equal to
0.
0. Okay. Now we will get two equations. This equal to 0 and this equal to 0. So if we solve these two equations, you will get y1 and y3. That's all. Is it clear?
Yes, sir.
Okay. So this is one method by making use of this difference table. First to check how many values are given, then we can approximate that by a polynomial of degree something. Okay. So that will become a constant. So you go ahead and compute the higher powers also. Okay. And suppose only, so how will you solve the problems if only one is missing? Suppose assume that at 50 the value is given as 4. Only one is missing. So in that case, what you do? You go ahead and compute delta power
Delta power
4 also. So you'll get only
Yes, sir.
one value here. Right?
Then we put equal to 0.
Then it is 0. You put equal to 0, you'll get the answer. Okay? That is one
Yes,
way.
sir.
And the other method is without using the table. So this is how you have to work. So 3 values are given. So we can approximate by a polynomial of degree 2. So if we approximate by a polynomial of degree 2, the higher order differences are 0. That is delta cube, delta power 4 of y equal to 0. Delta cube is 0 for all y. Whatever y you take, that is 0. And delta power 4 of y equal to 0, etc. Okay. So here, how many values are missing? 2 values are missing. So we need 2 equations. So I take delta cube y0 equal to 0. In place of y, I have taken y0. And then in place of y, you take y1. So you will get delta cube y1 equal to 0. Right? Now what is delta? Actually, this I have told you in the second unit. Maybe in the next class, I will derive. For the time being, you remember. Delta equal to e minus 1. E is known as the shifting operator. In place of delta, you substitute e minus 1. Then expand this using a minus b whole cube. Then apply term by term. What is e cube of y0?
Y3.
E square of y0, y2. E of
Yes.
y0, y1. 1 into y0, y0. Similarly here. Okay. Now substitute whatever values you know. So you'll get two equations in terms of y3 and y1. You solve these two equations to get y1 and y3.
Yes, sir.
That's all. So can you take in place of y1, can you take y2? So if you take y2, what you will get? What is e cube of y2?
Sir, Y5.
y5. So whether y5 is there in the table, in the problem, it is given.
No, sir.
No, so you don't take.
Yes, sir.
Don't take y2. Okay. Similarly, instead of delta cube, you can take this also. You can take delta power 4 y0 equal to 0. So in place of delta, if I replace e minus 1, you will get e power 4. What is e power 4 of y0?
Sir, Y4.
y4. y4 is given in the problem. So there is no problem.
Yes, sir.
Okay. But in place of y0, if I take y1, Then what is
Then E4 of
then
Y1 is Y5
Wi-Fi? But Wi-Fi is not given in the problem. It
table.
is given only up to Y4. Only up to Y4 it is given. So whenever you choose the power and the Y value, you have to adjust accordingly such that you get only those values which are given in the problem. You are not going beyond that, either Y5, Y6, etc. Is it clear?
Yes. Yes, sir.
Okay. So that's all about this problem. Okay. So I'll stop up to this. I'll continue tomorrow. Okay. So your attendance is open now. You can fill it up only. Okay. Just fill the attendance and leave.
Thank you, sir.
Thank you. Bye.